Right. According to the question, it says two different events A and B are mutually exclusive. Okay? Two events are mutually exclusive. What do you remember by those two words, mutually exclusive? In terms of the definition, what are mutually exclusive events?
They cannot have.
Thank you. So, mutually exclusive events are events that cannot take place or happen at the same time. Right. Now, if you want to answer this question, you are given some information which says it is further given that 3PB is equal to PA. So, 3 times the probability of B is equal to the probability of A. So if I were to ask you, which one is greater, the probability of B or the probability of A? Which one is greater? The probability of A. Right? Now, when you're answering probability questions, it's always wise to use common sense as well. Okay? It's always wise to use what? Common sense. So here, we are given 3PB is equal to PA, and we are also told that the probability of A or B is equal to 0.63. Now, we did mutually exclusive events, and I gave you a formula or an identity for mutually exclusive events. What is that formula? What is the formula for mutually exclusive events? So it will be PA or B is equal to PA plus PB. Yes?
Now, mutually exclusive.
It's mutually exclusive events.
So there's no.
Okay. Now, this question, I'm going to show you two methods of doing the question. One method using the identity for mutually exclusive events. So we can call this one method 1. Because of the nature of this class, I need to provide you with that information. Okay, if it was probably another class, I might not tell you more than one way of doing it. Okay, so method 1, we use the identity for mutually exclusive events. Method 2, we use the addition rule. Both methods are acceptable. Okay, so this is the identity for mutually exclusive events. So the first mark will be given for that equation. Okay, when you write examinations at metric level, you are not given this formula. Okay, you have to memorize it. Remember, I told you in the past that it's only the one for addition rule which is provided. Then let's substitute now the given information. Can you pay attention there? Pay attention. The probability of A or B is 0.63. Your heartbeat should not increase because you saw a question of this type. You just have to know your formula, know your basics, and then you just substitute. So the probability of A or B is 0.63. The probability of A, okay, is it given? Huh?
Yes.
What is the probability of A? 3 times PB. Common sense should tell you that since we have got PB here, if I want to calculate the probability of PB, it's better to convert the probability of A to a probability of what? Of B, using that equation. No need to be scared. Right? So this will be 3 times the probability of B plus probability of B. Okay? Yes.
So is it fine if you did it the other way around?
Yes, we'll talk about that later. Right? We'll talk about that. Because some learners would determine the probability of B by saying PB is equal to a third the probability of A. Okay? What that means is where there is PB here, they will put a third times the probability of A. That's also correct. Okay, so whichever way you decide, as long as it's mathematically correct, that's fine. What that means is, for this question, you can end up having 3 methods, including that the one which shown is just this one too. That will be method 3. Okay, but method 3 will be almost the same as method 1. Right, so here, we now have a simple equation, isn't it? What is 3PB plus PB? 4. That will be 4PB. So this will be 4 times the probability of B, and this is equal to 0.60. Okay? Then, to calculate the probability of B, it's basic division. Basic division. Divide both sides by 4. Okay? So you get the probability of B is going to be equal to 0, what? If you divide 0.63 by 4, what answer do you get? 0.16. Okay, 2 decimal places will be 0.16. Alright, so it's 3 marks. The mark allocation, okay, the second mark will be for substitution. Okay, the last mark will be for the answer. Unfortunately, for a question like this, there are no CA marks allocated. Yes?
So if the question doesn't say that you need to write as a decimal, you need to as a fraction.
Yes. Yes. Okay. Okay. My previous lesson, I'm also teaching probability in grade 10. So both grade 10 and 11 we are doing probability. Now it's important for you to know that probability, in terms of the answer, there are three possible ways of writing the answer. You can write it as a common fraction. You can write it as a decimal fraction. You can also write it as a what? Percentage. Now, I can challenge anyone who says we should convert this answer to a percentage. Because in maths we've got what are called equivalent forms. It's not necessary to convert this 0.16 to a percentage. Because 0.16 and 16% are the what? Are the same. It's not necessary. And it's not necessary as well to convert this to 16 over 100 and then write 4 over 25. It's not necessary. As long as your answer, remember your answer for all your probabilities must be between 0 and 1. Also, if it's a percentage, it will be between 0% and what? 100%. But if the question does not specify whether your answer must be as a percentage or not, there is no need to convert it to a percentage because there are equivalent forms in maths which you are taught in grade 8 and what? And 9, isn't it? So a common fraction can be written as a decimal fraction. It can also be written as a percentage. You waste time in an examination. I saw this when I was marking the maths paper 1. Some learners write this and then they convert to a percentage. There is no need for that because of equivalent forms. Okay, unless if the question specifies that leave your answer as a percentage, then you have to strictly follow the instruction. But otherwise, we stop here. This will be the final answer. But we know it's also equal to 16%. We know that it's equal to 4 over what? 25. All right. So this is how you do the question. This is method 1. Okay. Is there anybody else got a question? Yeah, okay. But let's talk about method 2. Now, method 2 involves using the addition rule. Okay. What does the addition rule say? What does the addition rule say? Don't forget you are writing a test, come term 4, and I've already started setting the test. And these are concepts that are going to come in that test. And I told you, no holiday yet. Your holiday is after November. No holiday yet. Okay? So what's the formula for addition rule? P what? Okay, if you start by writing as PA and B, then the right hand side will be what? PA plus what? PB minus PA or B. So let me just close the door because my viewing is affected. Okay. Now, I know that some of you may be asking, how come Sean said it's PA and B or PA plus B minus PA or B. Right. This is correct as well. Okay, but generally the addition rule starts with PA or B. But it's exactly the same. Okay, it's exactly the same. The only thing which happens here is that these two swap their positions. Those two. Okay, they swap. So you can decide which way you prefer. Generally, for me, I prefer to start with PA or B. Okay? You might decide to start with PA and B, like Sean. It's still what? Correct. Is that clear to everyone? It's the same equation, but the subject is different. Okay, so PA or B, B equal to equal to probability of A plus probability of B minus probability of A and B. It's one equation which can be written in two ways. Okay? You have to make a choice as to which way you prefer. But I'm not going to restrict you and say memorize it as PA or B equal to PA plus PB minus PA and B. But this is the most common way. When you write metric, they provide that out. But if you prefer the first one, which Sean told us first, it's also correct. Is that clear then? Yes. Right, then, based on the information that we are given now, we are given, okay, let's do it based on Sean's formula, one that he likes. Okay, what is the probability of A and B if the events are mutually exclusive? It will be what? 0. So we put 0. Right? The probability of A, now let's do it based on what he suggested. So we are going to combine addition rule and what Sean said earlier. Instead of writing the right-hand side, converting PA, okay, to 3PB, let's convert PB in terms of A. So we're going to substitute this. Okay, so I'm incorporating method 3 and addition rule together. Okay, so where there is PB, we are going to put 1 over 3 times probability of A. So this will become the probability of A plus a third times the probability of A. Right? Fortunately, remember I'm using the first equation. I could have used the second one. They are one and the same thing, but I'm using the first one. So I need to substitute the probability of A or B. And it's given here as what? 0.63. Okay, so we substitute here 0.63. Are you following that? Then we take the minus 0.63 to the left, becomes positive. Obviously, probability of A plus the third times probability of A will give you what? 24 over 3, okay, times the probability of what? A. So this becomes 4 over 3 times the probability of A, okay, right? Like that. Then, if you cross multiply both sides by 3, you get 1,89 is equal to 4 times the probability of A. Then you divide both sides by 4. What answer would you get? Don't round it off yet. So your probability of A would be equal to what? Can you speak up this? 4725. You know that if you speak with a low voice, it shows that you don't have enough confidence. Right. I'm sure you can hear me speaking that I have what? Confidence in what I'm saying. So probability of A is going to be equal to 0.4725. Now, does the question want us to calculate probability of A? No. So this method can be a little bit longer, even though you eventually get the same answer, but it's a little bit longer. So when I was marking a number of, a few learners used this method. It was not many of them. But obviously the whole question itself, it was like a disaster. Right? So, okay, so if you want to calculate the probability of B now, we go back to that equation. So the probability of B is equal to a third times the probability of A. Okay, so let's go to the next page. So the probability of B is equal to the third times the probability of A. So that will be equal to, okay. So this becomes the third times the probability of A. Please, in this case, because the probability of A is not our final answer, don't round it off too soon. Okay? You have to use it as is from the calculator. If you round this down or up, it can exaggerate your final answer. Okay? So it's 0.4725. So this will be 0.4725. What is 1/3 of that? 0.1575, which is to two decimal places, that will be 0.16. Okay? Which is the same answer that we got using the equation for mutually exclusive events. Are you following them? Okay? So this is how you should answer any question on mutually exclusive events. Okay, these questions are very common if you do your own practice at home, past examination questions, and so on. You will encounter questions on mutually exclusive events. Okay, they are very common. But be aware that this is grade 10 work. It's not grade 11. It's grade 10 work. Okay, any questions? Okay, let's move on to the next question. Okay, the next question, I felt when I first saw this question here, I felt like our matrix things were made easier for them because the pictures of the cards were provided, which makes things a little bit what? Easier. Yes. So you have got two cards from a regular deck of 52 playing cards. Okay, that's shown below here. If you do the counting, there are 52 of them, right? And they are drawn at random, one after the other, without replacement. Okay. Remember yesterday I did an example on 3 diagrams where there was no replacement, where the probability was changing because of no replacement. Right? Now this question, it doesn't tell us about doing a tree diagram, but sometimes you can get a question which is not straightforward like this, where you might need to draw a tree diagram as part of your solution to the problem. Okay. But the first question can be done without a tree diagram. It can be done directly without a tree diagram. So let's do the first one, 13.2.1. So the first question says, calculate the probability that both cards are picture cards. The question will be, how many picture cards do we have here? 12. 12. So, our picture cards are there. That's where they are. There are 12. 12 out of what? 52. So you have got a deck of cards. That's a regular one, no jokers. Okay? So if you want to take on, before you move on, first, know your total in the sample space. Okay? Your total in the sample space is very, very important when you are calculating probabilities. So the total in our sample space is 52. Then, in terms of our event, okay, here our event is drawing 2 picture cards, okay, but there is no replacement, which means if I put my hand into the box of the cards, I take out a picture card, I put it aside, how many are left? 51. 51. And those 2 events, what do you call them? Independent or dependent events? Dependent events, right? Because the second activity it is affected by the first one. Okay, the probability of the second activity changes due to no replacement. So this will be P or picture card. Okay, so if you put your hand in the box and you pick a card, a picture card, the probability is going to be 12 over 52. Okay, but you don't put it back. So the sample space changes from 52 to what? To 51. Okay, so you put your hand again, you are going to end up having 11 over what? 51. Okay, if you do the calculation, you should get 11 over 221. So that would be your answer. Okay. Now let's draw a tree diagram and verify this. Huh? Let's draw a tree diagram to verify this situation. Okay. I've done the question without a tree diagram, but it can also be done with a tree diagram. I'm only talking about 13.2.1. Okay? 13.2.2 is more complex than 13.2.1. So to do the second one, you really need a tree diagram. Okay? So, let me call a picture card, I'll call it P. If it's not a picture card, I'll call it NP. Or you can use another notation like him. I think he prefers P prime. So you have got the first activity of picking the first card. There are two possibilities. You can either pick a picture card or you can pick a card which is not a picture card. That's the first time you put your hand into the box of those cards. There are two possibilities. You can pick a picture card out of the 12, or you can pick a card which is not a picture card out of the remainder, which is about 40. Okay, so the probability of picking a picture card first is going to be 12 over 52. Okay? Obviously, by now you should know that the total of the probability for any branches for any specific activity it adds up to what? To 1. So if you subtract 12 over 52 from 1, you should get 40 over what? 52. Okay? Or you can just subtract the 12 cards from 52, you get what? 40. Right? So let's say the first time you pick a picture card first. The second time you do it, now there is no replacement. So the total in the sample space drops to what? 51. So you can still pick another picture card, or you may pick a card which is not a picture card. So if you pick a picture card first, what's the probability of picking a picture card second? So that becomes 11 over 51. Right? Now, if you subtract this from 1, you get what? 40 over 51. Are you following that? Right? Then, it's also possible that the first time you put a hand into the box of those cards, you may pick a card which is not a picture card first. Then the second time you pick a picture card. Okay? So what's the probability of picking a picture card second? What? It will be 12 over 51. Okay? Obviously, the probability of picking a card which is not a picture card again for the second time will be 1 minus this. So you get what? 39 over. Okay? So your combined outcomes, okay, it will be PP, and then you can have PNP, and then you can have NPP, and then NP, NP. So those are the combined outcomes. Okay. So let's just go back to the first question. Remember, I say the first question will be done without a tree diagram, but you can be done with the tree diagram as well. So if you want to pick both picture cards, it means you multiply 12 over 52 times 11 over what? 52. Okay, sorry, 11 over 51. Okay, and then you get your probability, which will be the same as this 11 over 221. Are you following them? Right. Then, the next question now, it says at least one of the cards is a picture card. At least one of the cards is a picture card. Okay? Now, this question can be done in two ways actually. You can go back to the tree diagram and identify where you have got at least one picture card. So, we have three possibilities. We have got two picture cards there, then we have got one here, then we have got one there. Obviously, we don't need a picture card, so we don't need that combined outcome. You see how easy the question becomes in. You see how easy it's going to become. Yeah. So, I'm doing a detailed analysis of this question for the whole grade in grade 12. Right? 129 of them wrote it. So I listed all their marks, everyone in the grade. So I'll do a 5-number summary, do a box and whisker, and find out whether the distribution was what? To the left or to the right? No, I'm serious. I'm serious. You see, I got so interested that I just decided to put it on a spreadsheet for every learner, 129 of them. So I've got the marks of every learner for this question. Okay, and I'll share with you.
You see, we already just teach math, we use math.
Yes, because it's a practical subject. All right, so let's get on now and find the answer. Okay, let's find the answer from the tree diagram. So if I want to get that, so you need probability at least a picture card. So this will be equal to 12 over 52 times 11 over 51. So that will be 12 over 52 times 11 over 51 plus 12 over 52 times 40 over 51. 12 over 52 times 12 over 51.
40 over 51, so.
Oh, sorry, 40. 40. Okay, that's 40 over 51. Okay, that's 40 over change this one here. Right? Then plus the next one, it will be 40 over 52 times 12 over 51. So that's 40 over 52 times 12 over 51. So if you do the math, you get 7 over 70. Right? So there's 7 over 70. Okay. So that was the question. Okay. Honestly speaking, when I first saw this question here, I didn't see it as a very challenging question. Yes, sir?
So I got the answer right, but again, I just took the whole branch of the. I just took the entire branch.
Which entire branch?
So you wanted at least one picture card.
Yes.
So I took the entire top half.
The entire top half.
Yeah.
So this
just 12 over 52 plus 12 over 4. 12 over 52. So the second half of the diagram on the top half of the diagram.
So, okay, the 11 over 52 and the 40 over 50, the 11 over 51 and the 40 over 51, they together equal 1. So you don't have to go through all the mathematical hoops. You can just use 12 over 52 and add it with the probability of the picture card in the bottom.
Okay, that's quite interesting. That's quite interesting. So you see, he's seeing it in a totally different way from how I saw it, right? But it's still acceptable as long as it's mathematically correct to be acceptable. Right? Is there anybody who has got a question? Right. The last thing, okay, because of time, I just want you to know that it will also be done using a second method, or maybe you can say third, if you consider Sean's method as the second method. The third method would be find this probability. Can you pay attention, please? Pay attention. Pay attention. Okay, I told you that you might see this in your standardized test, your November exam, next year as well. And then some of you behave like you never taught this. You can also calculate this probability, the probability of no picture card. Okay? Then you subtract it from what? And then you subtract it from 1. Are you following what I just said?
Yes.
So you can determine the probability of no picture card. Then subtract that from what? From 1. You get the same answer. Because the question is asking for the probability that at least one of the cards is a picture card. So you can have one picture card, or you can have a maximum of what? 2 picture cards. So what is the probability that there is no picture card? You subtract that from 1, you get the same result. In that case, you'll be using the complementary rule. Okay. Right. Any question? Right. If you don't have a question, then